So let me summarize the main idea for building least common denominators. To build a least common denominator for a list of rational expressions, first you want to multiply the prime factors of each denominator. Take each prime factor the most number of times it occurs in any single denominator. Build a table like the one in the previous examples if it helps. So let's now take a look at where we find the least common denominator for rational expressions. The first example involves monomial denominators. Let's find the LCD for 7 over 8x squared and 13 over 6x to the fifth. Recall our first step is to factor the denominators. So 8x squared is 2 times 2 times 2 times x, and 6x to the fifth is 2 times 3 times x times x times x times x times x when written in prime factorization form. Then we count the prime factors. Notice there are 3 2's and 2 x's in the first factorization, 1 2, 1 3, and 5 x's in the second factorization. So what's needed in the LCD? Well, when we look at the number 2, there are 3 2's and 1 2. We take the greatest number, so we'll need 3 2's. There's 1 3 and no 3's. The greatest number is 1 3. And then x's, there are 2 x's and 5 x's. The greatest number is 5 x's. So we'll need 3 2's, 1 3, and 5 x's. Multiplying those factors in the final column, we obtain our LCD. Our LCD is 3 2's, 1 3, 5 x's, which when multiplied together gives us 24 times x to the fifth. Let's now work some examples together. Example 1a. Find the least common denominator for each list of fractions. 2 over 3y and 1 over 4x. Alright, so let's start by drawing a box. You don't have to, but I find that it's easier to organize my information that way. We begin by factoring our denominators, 3y and 4x. 3y, that factors as 3 times y. 4x, that factors as 2 times 2 times x. Now we count the prime factors in any given factorization. Notice we have 1 3 and 1 y in our first factorization. And we have 2 2's and 1 x in our second factorization. Now, what's needed in our LCD? We first look at the number of 2's. 2 2's is the greatest number it occurs in any single factor, so we need 2 2's. 1 3 is the greatest number of time any 3's appear in a factorization, so we need 1 3. 1 x and 1 y. That's the most number either of those variables appear, so we'll also need 1 x and 1 y in our LCD. This means our least common denominator, our LCD, consists of the following. It's 2 2's, which is 2 times 2, 1 3, 1 x, and 1 y, which when we put them together gives us 4 times 3, which is 12xy. That means our least common denominator of 3y and 4x is 12xy. Example 1b. Find the LCD for the following list of fractions. 3 over 8a squared b cubed and 5 over 12 a to the fifth b. We start by writing the prime factorization for each of our denominators. 8a squared b cubed and 12 a to the fifth b. The prime factorization of 8a squared b cubed would be 2 times 2 times 2, which gives us 8, and then a times a, which gives us a squared, and then b times b times b, which gives us b cubed. The prime factorization of 12a to the 5th b would be 2 times 2 times 3. That gives us 12. And then 5 a's multiplied together, that gives us a to the 5th, and then 1b. So now we count the prime factors that occur in each factorization. We get the following. There are 3 2's, 2 a's, and 3 b's in our first factorization. And there are 2 2's, 1 3, 5 a's, and 1 b in our second factorization. Now we need to list the greatest number of times any single factor occurs for our LCD. Looking at the 2's, there are 2 2's and 3 2's. The greatest number is 3 2's. We have only 1 3 because 3 only occurs one time, and that's in the second factorization. We have 5 a's because 2 a's versus 5 a's, the greatest number would be 5 a's. And then finally, 3 b's because 3 b's is greater than 1 b. This means then that our LCD is comprised of the following. Our LCD consists of 3 2's, or 2 times 2 times 2, 1 3 times 3, 5 a's, 1, 2, 3, 4, 5 a's, and 3 b's, b times b times b. That means our LCD is simply 2 times 2 times 2 times 3, which is 8 times 3, which is 24, 5 a's, which is a to the 5th, and 3 b's, which is b cubed. Our least common denominator is 24a to the 5th, b cubed. Now, before going on, I will point out that some of you might be able to achieve this faster without drawing a chart and just looking at your numbers and saying 24 is the smallest multiple of 8 and 12, a to the 5th, a squared. Well, there are 5 a's here versus 2 a's here, so a to the 5th is the biggest number, and there are 3 b's and 1 b. 3 b's is the biggest, and some of you might be able to jump straight from here to here, and that's okay. But for those people that might be a little confused or want to practice a technique over and over again for when things get a little more complicated, I strongly encourage you to continue using the box or the chart method.